Good morning, everyone, and thank you so much for joining today on our call. We're just going to give it 2 more minutes, and we're going to start at 7 after. Please stay on the line. We have a very compelling presentation for you here, and we're looking forward to it. Thanks. All right, let's get started. Thank you all so much for joining today. We are very lucky to have Joe Gagnis here. He is the VP of Network Technologies at Touchbase and has put together a very interesting presentation for us today. Just a few housekeeping items. We will be recording this and sending out the presentation after. If you have questions at all during Joe's discussion, please feel free to add them to the Q&A panel to the right of your screen. And without further ado, Joe, the floor is all yours. I am going to pass you the ball. Thank you so much.
Thank you, Christine. Today we're going to talk about this wonderful thing called software-defined networking. This is meant to be an introduction session. I'm going to scratch the surface of a lot of different topic areas, and we're going to give you a really good kind of well-rounded view of what software-defined networking is. I'm bringing up the PowerPoint here so you can all view this. There we go. All right. And so today's agenda, we're going to start off with some session goals. Let me tell you kind of what I expect you'll be able to learn from this session here. I'll give you an overview of why software-defined networking is important. You know, why are we looking at this as an industry, and how has it gotten the attention that it has? Going from there, I'll dive into some software-defined networking fundamentals. These are fundamentals that kind of apply across the board regardless of which virtualization topic it is that we're referring to, whether it be you know, a Cisco ACI solution, whether it be VMware, NSX, or you know, whether it be an OpenStack type solution. Going in from there, we'll talk about the Cisco ACI, the Application Center Infrastructure. I'll give you an overview of the VMware SDN solution called NSX. We'll talk about OpenStack, which is kind of the open forum, community-developed SDN platform. And then we're going to round this out with talking about the skill sets that are needed to take this on in the future, And, what type of things should you be, looking at and learning about now so that you're prepared for it when we start to see some traction out there. And then at the very end, I'll give you some recommended resources, some things that I found were very helpful to me as I've been picking this up, and want to share some resources with you all. So a little bit about me. My name is Joe Gagnes. I'm a CCIE. Been working with networking back since 1997. Kind of, my entire career has been really focused around networking space. And I learned about SDN, started learning about it back in 2012, kind of when this was starting to be circulated a little bit more, and back then, one of my concerns was, is this going to replace my job? Is this going to, force me to look at another career? So we'll talk about some of those things in here. Don't be worried about that. There's still plenty of opportunity for network engineers. You will need to learn some new skills along the way, but I'm excited about where it's going. And so we'll talk a little bit about, our career progression, further in the slide deck. One of the goals here is to provide you an introduction to software-defined networking, give you some foundation on SDN terminology, and then talk with you about what a common deployment architecture looks like. And there are some differences between a traditional, typical networking architecture versus what we're seeing is being built for a software-defined network architecture. And we'll take a look at some of those. This presentation will be Cisco focused. You'll see that most of the topics in here, where I talk about VMware, you'll see that I'll be tying it back to Cisco. Where we talk about OpenStack, we'll be tying that back into the Cisco solutions as well, and kind of give you a footprint from how Cisco's viewing some of these other technologies and how they all interoperate with one another. Some of the things I'm not going to be covering in here, I won't be going into a comprehensive review today on any of the topics. I want to make sure that I don't lose anybody 10 minutes into the session. We do intend to have follow-on presentations out of this, and so look for those in the coming months. And we'll dive a little bit more deeper into some of the different topics that are discussed here. So if you're interested in that, please let us know about it, and look for those invites when we return to some of these topics. And then lastly, I will not be covering it, Python or JSON or XML, other programming tools that are out there. Right now I want to scratch the surface and kind of give you all a very broad view of what this thing is about. And then, in future sessions, we'll dive a little bit deeper into, how do I do some of these things with Python or JSON. Okay, so why software-defined networking? Why are we even having this discussion? One of the big things at Cisco Live this year was this messaging that John Chambers put out there about, in 10 years, only 40% of the companies that are out there today will continue to exist in a meaningful way. And the main reasons for that is the speed of innovation that's out there, the low cost to enter some of these traditionally difficult markets to enter due to cost, due to barriers of entry, and lastly, the speed of product development and invention. John Chambers pointed out a couple very pertinent examples: Airbnb, Uber, as being some of these companies that have taken, in relatively short time, have taken their relative industries by storm. And, these are the things that companies need to look at today for themselves. They need to disrupt themselves and be continuing to look at how can we do things faster with less cost so we can keep up and we can pull ahead and be relevant in 10 years. The SDN, the software-defined networking movement, is largely credited with this program that Stanford began back in 2000, I believe it was 2010, called Clean Slate. And the questions they asked their research students was, if we could reinvent networking, what would it look like? How can we do it better? Throw away everything that we've had in the past, and what can we do to make it better? And so that was kind of the start of SDN thoughts and leadership in this space. some of the aims of SDN is to, remove or decouple the control plane from the data plane, remove the intelligence from the forwarding and the packet switching. We want to centralize the intelligence of a network, utilize controllers, similar to what, the wireless industry went through several years ago, where today you see a controller-based infrastructure that's managing a whole variety of wireless access points. And so we're applying some of those same principles now to networks, and how can we do things in a more intelligent way or in a more automated fashion and be able to get more done with less resources. Okay, some of the things that software-defined networking isn't, and these are some of the lessons that I've learned as I've been pursuing this over the last several years. It's not an easy button. You'll hear some vendors out there tell you that SDN will be the solution to everything, that there will be menu-driven wizards to do networking. I'm here to assure you that that's not the case, at least not anytime soon. SDN should simplify the management of your network. It should make it easier for you to accomplish more with less time and less resources and minimize your errors. But it's certainly not a replacement for network engineers and the jobs that network engineers do. One of the things that I'm often asked is, well, if anybody can do these things, if a programmer can do the work that a network engineer can do, what's my place here? And my response to this is that, a lot of programmers come from a different, they come from a different background. And so network engineers, we've spent many years learning about quality of service and oversubscription and circuits and, all of these types of things that, give us a unique background to tackle these problems in the network space. So we've all learned along the way. We've solved a lot of networking problems. And so we have these scars that we can bring to the table when we start talking about automating networks. So there's still a need for network engineers. That background that you have, knowing these different technologies, will be very valuable in the future to help them to automate networks. Programmers need you, DevOps folks need you guys because you have that background. You have the understanding of quality of service and committed information rates and so on and such forth. Bullet point 2 here is, networks are getting more complex, day by day, year by year. Turnaround times are getting more demanding. Years ago, we started to see that, the server virtualization folks had started to add a lot of tools on their side. They're using Puppet and Chef, and they're able to pull, turn out compute workloads in minutes. And so a lot of times that creates additional pressure on the network teams to keep up with that demand. I listed in here, just an example of some of the tasks that network engineers go through when deploying a brand new application. And, you look at these tasks and you think, wow, there's a lot of things that we really do and a lot of time that we spend to set up new applications. We create and configure VLANs, we assign interfaces, we have to go through and configure quality of service on each and every single switch and router from end to end. And then on top of that, we have firewalls and access lists and load balancers and all the other things that go into deploying an application. So there's a lot of things here that we can automate, that we can do better, that we can do in a more rapid fashion. And so SDN is a way of tackling some of these issues and allowing us to do more with less. Okay, some software-defined networking fundamentals. So the purpose of this section of the slide deck is to show you some things that kind of apply across the board, whether we're talking OpenStack, whether we're talking VMware, or whether we're talking Cisco. And so these are just some fundamental things that projects like Clean Slate have brought to the table with, hey, if we could restart over, how would we do it better? So on the screen here, you see the typical network topology today. Every device is deterministic. Every device has intelligence built into it, and they make their own autonomous decision on what to do with each and every packet. do I allow this or permit this, and where's my next hop at, and, do I need to apply access lists to it? But it's hop by hop, device by device, and if any one device here is out of sync with the others, we have performance problems, we have applications that don't work, and we don't really have a unified policy across all the devices in our network. So in SDN, one of the things that we want to turn kind of on its head is this idea of having a centralized intelligence platform. We call those controllers here, and the controller's purpose in life is to provide policy to all the networks or all the devices in the network. We aren't removing all the intelligence from those end devices. We still expect routers and switches to have some intelligence, to be able to, process packets on their own, to have their own route tables and know where to forward packets. So we're not going to be dependent upon a controller to make our day-to-day decisions on what to do with the packet. But what we want to do is we want to use a controller to help push policy, to help keep things uniform, to help deploy policy quickly, and to keep up with demands and make the network engineers' jobs a little bit easier. Okay, I have a slide in here on declarative versus imperative models, and this relates a little bit to that last slide. And there's several different ways to approach programming. If anybody's ever done a C programming course, you'll see that it's very imperative in the way that it approaches its philosophy. We're going to tell, in a C programming or an imperative programming language, we tell the device step by step what to do. So you're going to do item A before you do B, before you do C, and you have to dictate each item along the way in order to do that. Declarative models, on the other hand, we tell it what we want to have accomplished and leave it up to the remote device to figure out the best way to accomplish that. I have an example in here that I think will help kind of cement that a little bit. If we have an air traffic controller, the air traffic controller would tell a pilot, what runway to use, but it's not going to tell the pilot necessarily how to land the plane. And so that's an example of a declarative model. So the air traffic controller would be our network controller, telling the device what to do, but then we're trusting the device to know how to execute on that policy to accomplish the end goal. So when you're thinking of this, think of the what. What do we want to have as the end state? What is our goal for this? And then we're going to depend on or rely upon the intelligent devices out there to execute it the way that it needs to be done. So we're not removing all the intelligence from the network, we're just utilizing it in a better fashion. An example of declarative model program that's used day-to-day is SQL programming. That's one that most of you are probably familiar with, and just want to let you know that it's something that is a proven technology. It's out there, it's being utilized, and we're using those same principles here. So now I want to go into the application-centric infrastructure. Most of this slide deck is in this area. This is the Cisco approach to software-defined networking. And we're going to barely scratch the surface on this. At the end of the slide deck, you'll find a lot more information about how you can get involved in this and learn a lot more information about ACI. So ACI is Cisco's turnkey solution to SDN. It provides security, it provides a centralized management platform in the means of a controller. It provides compliance capabilities and the ability to scale. And we'll take a look at how we accomplish some of these things in the coming slides. Some terminology. When we talk about ACI, there's several different terms that are kind of thrown around, and I wanted to make sure that before I got into some specific examples that you kind of know what it is I'm talking about, where we're coming from. A tenant is just a logical container for resources. If any of you have ever worked with a multi-tenant environment, there's isolation between each of these environments, and there may be different customers or different, production versus development versus staging, et cetera. And so that's all we're talking about. A tenant's just a logical container that's isolated from the other tenants. endpoint groups in ACI terminology is just a logical grouping of these services or devices in some similar fashion. That fashion may be a VLAN. It may also be something completely abstract, such as in a 3-tier application, how you have a user interface, an application tier, and a database tier. And so you could take each of those tiers and you could define those as an endpoint group. So there's a lot of different ways that you can do endpoint groups, and the unifying message here is that you want to kind of group your endpoints by their function or by some kind of policy. The idea here is that these devices in this endpoint group all behave similarly in some kind of fashion that you're going to apply policy to. And then an application network profile is where we take all of these different endpoint groups and we call that an application network profile. A great example is just taking an application and having 3 different tiers in there, and one endpoint group may be our user interface endpoint group, another one may be our application endpoint group, and then finally our database endpoint group. If I combine all of those together to define an application network profile, or in other words, an application, that's what we're talking about. In the diagram at the bottom there, you'll see that I have an EPG, or an endpoint group for web, one for application, one for database. There's a provider and a consumer between each of these endpoint groups. That's the inbound and outbound policies that's defined there. In ACI terminology, those inbound and outbound policies are called contracts. And contracts can be unidirectional, they could be bidirectional. There's a lot of value in defining your contracts to be unidirectional, so you have more ability to customize those and not kind of trap yourself into a formation that you're stuck with. This slide deck, what I'm trying to do is more illustrate, what tenants are. In this example, we have a tenant A and a tenant B. And tenant A may have 2 completely different private networks versus tenant B that has its own private network. These could also be the same network space. Again, it's the multi-tenancy idea. But they're isolated within the tenant group. So they can't see one another, they can't talk to one another unless we provide contracts or policies in between the 2 of them to allow that. And then finally, at the bridge domain level, this is where we typically think of VLANs. A lot of times the bridge domain is equated with a VLAN. There's some technical differences between those and how you set those up and how you define those. But for our purposes right now, it's probably easiest to think of these as subnets or VLANs. Okay, this deck right here is all about the diagram you see here. In an ACI infrastructure, we have the concept of leaf nodes. Leaf nodes are the interface between your existing networks today that don't run programmable networks and the ACI or the programmable part of your network. You'll see that what we have here is a recommended topology for ACI, and it's a little bit different than what you will probably be running today or what you recognize in your network today. There's not a concept of a core aggregation and access layers. One big reason for that is that, in a traditional network, if you lose a core today, that's a pretty bad thing. You're going to lose 50% of your capacity. And so we spend a lot of money today in our networks and looking at things like mean time between failures and making sure that our core routers and switches are completely redundant, that they don't fail very often, that we have plenty of extra power supplies, and we have a lot of redundancy built into them so that we don't lose half of our capacity. In an ACI architecture, we kind of spin this up on its head a little bit, in that we don't have cores necessarily any longer. We have these things called spine nodes that run only ACI, and everything in this blue box up here is completely active. It's active infrastructure. There's no passive paths. We can utilize all of those links and utilize all the bandwidth that's available to us. And so one of our missions here is that the loss of a spine node affects far less of our bandwidth than if we had lost a core in today's network. So it's a lesson learned here that we're going to use all the paths, and we're going to create more spines, and then we're less dependent upon the failure, or we're less impacted by the failure of a spine node. At the bottom of this slide, you'll see some EPGs. These are just example EPGs, and you'll see that there are different types. And the reason I have this slide on there is to show you that an EPG doesn't necessarily have to be a group of VLANs. It doesn't have to be a group of users or a group of files, but they could be. It's completely arbitrary, up to you and what it is that you're trying to accomplish with your policies. And so I just have a couple examples there of how different EPGs may be set up and what they might look like. Okay, in an ACI infrastructure, we talked a little bit about how we have these intelligent platforms called controllers. And the controllers send out policy across your network, and they help program all your devices to meet a policy that we want to accomplish. The Cisco controller is called the Application Policy Infrastructure Controller, or APIC for short. The APIC, it's meant to be the policy enforcer of the ACI world. A couple things to know about it. It does have a GUI. So on release, you'll see that there's a GUI that you can learn with. And all of the things that we talked about, like setting up endpoint groups, can all be done in that APIC controller through the GUI. Applications can be configured in there. And so it's a great means to kind of get your feet wet with it and to learn about ACI and be able to manage it today without the need to know a lot of heavy scripting, without the need to know Python or JSON or XML. And so the GUI is your friend here. Those of you who do know programming or will be learning programming, there is a RESTful API that will allow you to run your Python, JSON, your Postman scripts directly against it, and it'll then turn those into policy and help you to push those out to your devices. One thing that I want to note is that there are two different flavors or versions of APIC that are out there, and they're not exactly equal. They were built around the same feature set or desires or goals, so they'll have the same look and the same feel to them when you're working with them, but they're built for completely different use cases. The APIC DC, the DC standing for data center, is built for high-performance environments, your data center in particular. It requires Nexus 9000s today, so those Nexus 9000s are where you are going to be living if you want to deploy APIC DC. The Nexus 9000s themselves do have two different operating modes. You have a Nexus mode that will help you bridge the gap until you're ready to go to APIC or ACI. And then there's the ACI mode that you can enable, and then it's all managed through the APIC. And then the other flavor of APIC is the APIC Enterprise Module, the EM. And the APIC EM is meant to manage your network as it is today. And so the APIC EM does interface with a wide variety of devices. It will interface with some of your ASRs out there, your ISRs that are out there in your networks, some of your Catalyst switches. You do want to take a look at the release notes on it. There are some devices that are supported, and there are some that are not. One thing to know about the APIC EM is that it, too, also has a GUI and a RESTful API. But then when you execute policy against it, what it's doing is it's converting those into CLI commands that are then executed on your routers and switches in your network. So it's built to manage your networks as they exist today and as you move into ACI. A couple things, the APIC today runs like a server. It runs on server hardware, runs as a virtual machine, and these controllers are a free download from Cisco today. You can go out to Cisco and download them. The APIC EM today runs in read-only mode, so you don't have to worry about downloading this thing, installing it in your network, and then breaking everything. So it is running in read-only mode today, so you can't hurt anything, but you can pull some useful statistics and reports out of your network today. And so it's a great way to kind of learn about the APIC and the interface that's there for you. VMware NSX. I have a couple slides on VMware NSX, and the main purpose of this is kind of highlight some differences and some similarities between the Cisco solution and the VMware solution. So the VMware NSX is an overlay technology. It's meant to ride upon your current network today, which separates it from having a reliance upon the hardware that you have deployed in your network. It's run completely from VMware. It does require the NSX manager, which runs as a VM, and you can push policy out from the NSX manager, which is kind of their controller in this environment. Some NSX terminology. NSX is dependent upon a technology called VXLAN. VXLAN is a method of encapsulating layer 2 traffic over a layer 3 infrastructure. And so what they're able to do by adopting this philosophy is they're able to get around the 4094 VLAN limitation that you see in a traditional network. Cisco has also solved this problem, by the way, but also just want to point out that NSX also has solved this problem, and it's a great use case for VMware. A couple things on the terminology. The virtual tunnel endpoint, or VTEP, it's a layer 3 IP address that is associated with an ESXi host. And it's the tunneling endpoint or the encapsulation endpoint between two nodes in an NSX environment. And then we have a concept called a VXLAN network identifier, or VNI. This is a 24-bit identifier, similar in idea to a VLAN, but notice it's 24 bits. And so we have a lot of space there, and you have a lot of space. You're not by any means constrained by a 4094 VLAN identifier. Let's see. So that last slide relates to this diagram right here. I'll explain this with the diagram up here. When you guys get this PDF, you're free to flip between the two of them, and the previous slide's a great reference to this one. You'll see in this diagram the ESXi hosts. There's 4 of them on the screen here, and each one of those ESXi hosts has a VTEP that's associated with it. And this is simply an IP address that identifies that ESXi host and the virtual machines that live on that VTEP. Above it, there's a big green line that spans all the way across all 4 of the hosts. And that's called a VXLAN 5001. This is your VNI, or in other words, your virtual VLAN. It's your VLAN that spans across all of your ESXi hosts and potentially your data centers, potentially different clusters. And so the hosts there on VXLAN 5001 in this example would all live on the same subnet, and they'd be able to communicate with one another by policy that's defined on your NSX manager. Your VXLAN transport subnets, you'll see that there's 2 of them here, these big blue dotted boxes, define kind of a logical boundary to help the VTEPs to scale well. And what we have here is that the VTEP1, for example, would communicate with its VXLAN transport subnet with changes in its virtual machines. As virtual machines and workloads come and go, it's responsible for communicating those changes within its transport subnet. And then it will also communicate it to a designated UTEP, and the UTEP would then propagate those changes within its separate transport subnet. So that's how it's accomplishing a lot of scalability in an NSX environment. So the question I get a lot of times, hey, which one's better? These sound like they're competing technologies. My view over the years, you know, when I first got into this, I thought, well, maybe there's some truth to that. I think where the industry has gone is that both of these can coexist at the same time on a network. And in many cases, they fit different use cases. ACI today, you can deploy for free. The ACI tools are out there, they're available to you, they're being implemented across all your platforms. Why wouldn't you use both of these technologies? ACI would view NSX as just another application that would ride upon the network. And NSX does have some use cases, and it allows you to be able to very nimbly create and destroy you know, certain compute infrastructure nodes or, you know, networks. And so there are some interesting deployment methods that both of these could use, and I think that they handshake nicely together. And you know, what I'm seeing out there in the marketplace today is that a lot of companies are looking to deploy or adopt both these technologies. OpenStack. OpenStack is kind of the open alternative to, you know, some of the proprietary solutions that we've looked at, you know, being you know, Cisco ACI, the ASIC, and, you know, the VMware solution. So OpenStack, you know, we're going to open up that code, make it freely available for people to you know, for the community to be able to edit and adopt and make changes to. And so these slides right here are meant to be an introduction to OpenStack. I have a lot more information at the end where you can go out and research this. There's several working groups within the OpenStack project. The one that we are most concerned about in the networking space is the project called Neutron. And there's a whole working group and committee dedicated to Neutron. OpenStack is a great orchestration platform. It will interoperate with ACI. It has plugins to ACI. And so, you know, OpenStack and ACI can coexist and work together to accomplish business goals. This slide deck right here describes Neutron at a very high level. You'll see that there's a number of agents on the left-hand side that are required in order to run, well, I guess they're not all required. Some of these are plugins. Out of the box, Neutron is deployed as a layer 2 switch, similar to what you would see in like a 1000V or you know, a V switch in a VMware environment. The network node plugins over here allow you to add on to that functionality. So you can add a DHCP server, L3 services. You can add on, you know, load balancer plugins. You know, and there's a whole number of plugins that you can add on to your network. The SDN service node, it's shown here as being out of band or being out of the data flow. And the purpose for that is that we want to be able to manage our network and not have every packet flow through a controller for decision. And so that's what we're trying to show here. And then in the middle, we have something called a compute node. The compute node is it's the NOVA working group, and you know they're another one of the working groups in OpenStack, and they have Neutron plugins there to help feed information both to and from you know, Neutron to NOVA, and keep everything you know, consistent and automated across the platform. We have a cloud controller node with lots of different add-ons and capabilities in there. Some of these are described in the previous slide. At the bottom, we have something called Horizon. That's the dashboard node. This is a GUI for Neutron as well as NOVA, and it's made to help make management, you know, simpler for all of OpenStack. Okay, I want we're getting toward the end of the slide deck here, and what I want to kind of talk about here now is, some of the skill sets that are, necessary to embrace this and take this on in the future, and kind of provide you with some of my advice to those of you that, are attending this for the first time, have never, really delved too much into SDN, and just provide some advice on things to learn now and, provide some resources to you. John Chambers this year at Cisco Live, one of the things he mentioned was, everybody needs to disrupt or be disrupted. And what he's talking about is, innovate yourself, innovate your organizations, innovate your companies. Don't wait for, these things to be thrust upon your companies or yourself. Take that first step and adopt these things. You will be happy that you've done it. Some DevOps methodology would be useful for network engineers as we move forward. I'm not saying that everybody needs to go out there and learn agile programming or agile methodology today, but some of those skill sets, some of those terminologies, some of those lessons that they've learned would certainly benefit all of us, as we're learning, automation. For those of you who are looking to add automation skills, Python is, in my opinion, far and away the technology to focus on. It probably has the most SDN support across, any of these other tools that I've listed here. JSON certainly has a good place, but if I was to tell you to focus on one automation skill for right now, it would be Python. There are several free classes out there that you can enroll in. Code Academy has a great program, as does Coursera. Some of the Coursera courses are taught by, local universities, and it's possible to even gain, college credit if you choose to take that. Third bullet point up there is to enroll in a free GitHub account. GitHub is a repository that, allows us to share resources amongst the community, and so enrolling in a free GitHub account would allow you to be able to pull down Python scripts and automation scripts, some of these CAN scripts that are ready to go, and you can learn and collaborate with others in this space. So a wonderful resource, and it's free. And then lastly, I encourage everyone to sign up for a free Cisco DevNet account. There's numerous benefits in it. The collaboration aspects are wonderful. You can, with a free DevNet account, you can go out and download for free the Cisco APIC and get that controller downloaded and installed on a VM, kind of start to learn how it works. And then here I have some recommended resources. There's a lot of links here about APIC. There's a book here by Lucian Avramov, wonderful book. I think it's the best book for learning Cisco ACI that there is today. There's certainly a lot of other books on SDN in general that I could point you to. And then at the bottom, there's a couple links to OpenStack and Open Daylight and how you can get involved. These are organizations that you can join, be a part of one of the working groups out there, and help contribute back to the community. And that is the end of our presentation. Christine?
That was great. Thank you so much, Joe. I have just one question in the Q&A, so if you have a second, do you mind running through it really quick? Okay, the question is, are there any specific requirements in topology or hardware for the spine and leaf nodes for ACI? And the answer to that is yes, there are. There's a number of data sheets out there that you'll want to refer to or talk to your Cisco partner, talk with us, and we can help navigate some of those waters with you. Some of the routers and switches out there have capability to be a spine or to be a leaf or to be both. And so you really do need to look at the specific switch or router to verify which position in the ecosystem it fulfills.
The Nexus 9000 is the Cisco ACI family that supports ACI, out of the box. And all those platforms, there are several different models that have different use cases. Some of them can only do spine. Some of those can do leaf or dual-purpose spine/leaf. So, my recommendation there is to look at us. Talk with us, and we can help you with that. Second question: how limited will an engineer be going forward without learning at least basic programming skills? And what can be done without it? So the answer to this, if you had asked me back when we were starting this, this conversation with Cisco back in 2012, I was very worried that everybody was going to have to become a DevOps engineer, that my role as a network engineer was going to change from, a command line centric focus to now I'm a programmer and, I'm interfacing with, the developers day in, day out. And over the years, we've seen the product set and SDN, mature. And with the advent and, the deployment of the Cisco APIC, that's the controller that Cisco has, the GUI has made big strides toward that to help bridge the knowledge gap that exists there. So, you're not required to be a developer, nor do I think that all the network engineers are going to step into this day one and be developers. I think that there will be a heavy reliance upon the APIC GUI, and then as our skill sets grow as a community, you'll see that we'll start to use that API and be able to automate more and more things from that and be able to do more powerful things as our skill sets grow. So no, there isn't a need to be a developer or a programmer today, but it would certainly be beneficial to all of us to pick up those skills and be able to contribute to the DevOps groups in that manner going forward. Only network engineers understand a lot of these problems that we managed to find a way to solve, with quality of service, with oversubscription. We live in this world. A lot of DevOps folks, these are new territories for them. And so they are certainly reliant upon us to help them out. Were there other questions?
I just got one more in a private chat, just asking, how will SDN relate to managed services? Essentially, will managed service providers support SDN, and does it change the model?
It will certainly change the model, and managed services are working hard to deploy SDN in their environments. Here at Touchbase, we certainly are working hard to deploy that in our infrastructure here. And, we're first working to deploy it to manage our network and then, be able to add those plugins and extensions into our clients' networks as well, so that we can automate and we can provide that visibility, uniformly and consistently across, all of our clients and, to be able to help, deploy and be more rapid in our response to you guys. So I think you're going to see a lot more demand for that in the MSP space in general. And here at Touchbase, we are working hard to deploy those capabilities today.
Awesome. Well, thank you so much, Joe. That's all the questions I had for you. For everyone on the call, thank you so much for joining. Again, this is recorded, and we will send it out with the presentation in the next day or so. So if you have any questions or need anything, I will also send Joe's contact information as well as mine. So if you have questions, please feel free to reach out. So again, big thank you to Joe. This is wonderful. The content was amazing, and we really appreciated having you.
Thank you, everyone. Appreciate your time.
Thank you, guys. Have a great day. Thanks.